Okay, so let's just pray. Father, we thank you for this class. We thank you, Lord, for this moment. I pray that, Lord, as we begin, grant us understanding. In Jesus' name, amen. Okay, so today we'll just look at rational numbers, and then I'll get to revise with you guys just a bit on complex numbers. But my main focus today is rational numbers. All right. Now, I'd love you to write down this. Hope you have a book and a pen, and write to say a rational number is a number that can be written as a ratio. So this rational number, you can see the first word here that is here is just the word ratio. Okay. So when we're talking about rational numbers, we're talking about ratios. So this is a number that can be written as a ratio of two integers. All right. A number that can be written okay, so this is simply a number that can be written as a ratio of two integers. All right. So a number that can be written as a ratio of two integers. So an example is A over B. So an example, e.g., A over B, and then you can write where, not this where, it is this one, isn't it? So where A and B are integers, so where A and B are both integers, all right? So where A and B are both integers, but B is not equal to 0. So B should not be equal to 0, because the moment you have 0 in the denominator, the answer is going to be undefined. So A and B can be any integers. And you know, when you're talking about integers, we are simply talking about negative numbers and positive numbers. So we're simply looking at numbers around the number line. So when we have these, and the ratio of these two numbers is called a rational number. Okay, so that is all about the definition in terms of the rational number. The only thing that you now need is just to know how to prove that a number is a rational number or not. Okay, so let us look at this. I would love you to write examples. Okay, so after these examples, I believe this was the only question that I felt was the one that we didn't do and we didn't look at. And I thought probably it was not going to be part of your quiz. So let us look at now examples of how to prove that a number is a rational number. So you can write express the following. So just write express the following. So express the following in the form. So in the form A over B. A over B. Okay, so usually this is the way that you're going to be given. And I believe it was the exact way that it's going to come. And I believe this question, obviously in your test, you will have these things. So I'll try by all means to be as fast as I can so that I can finish up everything. Okay, so let us have the first one. So the first one is going to be 3.3. Okay, now maybe before we go to 3.3, let us start with something. Okay, even this one is the same thing. So 3.3 bar. Now, whenever you see this bar on top, it just means recurring or repeating. So recurring or repeating. So if we have 3 bar, that means we have endless number of threes. They are continuing like this. They can go on and on and on. The threes are they are repeating. So if the threes are repeating, they'll just you just write it as 3.3 bar. Now there are steps that I'd love you to write when you're taught to express a number in rational form. There are only these 3 steps, and once you know them, then you can prove any rational number. So the first one, so step number 1, so you can write step 1. So step 1 is let x be equal to the original number. So the original number given that you want to prove. Okay, so in this case, we're going to say let x be equal to what? This, which is here. All right. Then secondly, the second thing that you do is, so the second thing is you need to move the decimal. Okay, so move the decimal point. So move the decimal point up to where you are going to have, so up to where you will only have, so where you only have the repeating decimal after the point, where you only have the repeating number, where you will have the repeating number after the decimal, after the decimal point. Now, no one is going to ask you to list these. It's just for your understanding and your studies after the decimal point. Okay. So I hope you have written that down because I will erase it. Okay. Then the third point, which is the second last, the third one that you now need to do is move the decimal point. So move again the decimal point. Covering. So move the decimal point covering, you understand this when you do the example, covering the repeating number. Covering the repeating number. So by covering, we just mean this one now comes to other side, but I'll show you in another example. So covering the repeating number. And now the last one, which is number 4, is subtract the last two equations. The last two equations. Okay. All right. So the last one is subtract the last two equations, and I'll erase everything. Okay, maybe let me begin. I think you can wrap that question 1 because it won't have all the steps that I want us to have. So let us have our example 1 as 2.13 bar. So this bar is only on 3, so it means our 3 is the one that is repeating. Now the first step that I said is move the decimal point, right? I said let x rather. So you say let x be equal to what? The original thing, isn't it? So your original is 1.3 bar, like this, isn't it? Then the second thing that I said is move the point. Okay, so move this point up to the place where we're only going to have the repeating number on our right side. So we're going to say, so how can we move this point up to the here? We know that when we multiply a decimal number by, let's say we have 100, okay, and we say times 2.313. If it's multiplied by 100, the decimal point only moves twice, isn't it? 1, 2, then it means it will come here. So in order for us to move a decimal point, you need to multiply by either 10, 100, 1,000, or whatever in order for this point to move. So in this case, since we want our point to only move up to the point where we only have the repeating number on our right side, that means we need to multiply by what? Who can try this out? And Nalisha, can you just help us? We need to multiply this number by what? By 10, 1, by 10 or 100 in order for it just to move 1 point.
10.
By 10, right? So if we multiply 10, that means whatever we do on the right side, we'll also do on the left side. So it means this x will become 10x because 10 times x is just 10x. Then we say it's equal to, then you multiply this 10 by this number, this point will move here, which is the thing that we want. So it will be 221.3, right? So we have our point, and we only have on the right side, we only have the repeating number. Then are we done here? Not yet done. What I said now, the last step was to ensure now that after this point, cover this repeating number. So what are we going to have? We need again to move the point up to where we're going to cover this repeating number. So by this, again, we're going to multiply. We need to have this point now moving up to here where we have this whole repeating number this side. So our third step now is we need to cover this repeating number. So we're going to do that. We need to move the point again, one side. So how are we going to do that? We're going to say 10. So multiply now this by another 10, isn't it, for it to move this side? That means we're going to have 10 times 10, which is just going to give us what? 100. So we're going to have 100x is equal to, now we're going to have, okay, sorry about that. I had a call, so I hope it didn't interrupt. Okay, so now we're going to multiply by what? By 100, so that we can cover this repeating number. This repeating number can also be on the left side. So how are we going to do it? We multiply by 100 so that it can come this side. So now we're going to have 2, 1, 3, right? Point. We know that these are repeating. So we'll have 3 bar like this. So having done that now, we can call this our equation 1. This is our equation 2. And this is our equation what? 3. Now I said you subtract the last 2, isn't it? So the last 2 will be these 2 here. So just get these 2 and subtract them, then you can find your x. So we're going to do this. So I'll repeat this. The first stage that I said is whenever you have been given something like this, always ensure that you only have the repeating number after the decimal. So we had our x is equal to the original, then we multiplied by x so that we can have only the repeating number on the right. And then we did this. Then the second thing is you need to cover now. Cover this repeating decimal to come as well on the right side. Then you're going to have the other repeating decimals. So of which we multiplied this in order for us to move again this point to the right side. To the right side, we need to multiply again by 10. So we have now 100x, then our 3 will be covered, which is here now. We have covered it. Then we say 0.3 bar, which is now also repeating. Then you will now subtract the last 2. So here, what are we going to have? We're going to say, now you subtract this one from, so you get this minus this. So we're going to say 100x minus x, okay, is equal to, so again, we get 213, which is the bigger one, 0.3 bar minus this 21.3 bar. So what is 100 minus this? This will give us 99x, isn't it? 99x is equal to, so what is this? Minus that, so we can just write it in the baby form. So 213.3 bar minus 21.3 bar, isn't it? So to do this mathematics, you know that this and this will cancel, isn't it? So this is just 0 here. Then you can say 0.3 minus 1 is just 2. Then here we have 21 minus 3, which is 19, isn't it? So we're just going to have 192 because this 0.0 means nothing. So we can just have 192. So this is just the same as having 192. Okay, then we're going to divide both sides by 99, this side as well by 99. So our x therefore is equal to 192 divided by 99. So one of the things that I forgot to add on the definition, I want you to add this. Go back to the definition where you wrote the definition. I said that a rational number is a number that can be written as a ratio of 2 integers, e.g. a over b, right? A over b, where b is not equal to 0. And then I want you to add this. A and b are integers. So where a and b are integers, and so where a and b are integers and are cofactors, I want you to add that. And they are cofactors. So by cofactors, I want you just to write this, cofactors. So they're cofactors, okay? So where A and B are cofactors. Or you can put in brackets, cofactors, or also called relatively prime. Relatively prime. Now, this whole thing is nothing complicated. What we mean by cofactors or relatively prime, we just mean that they are expressed in their lowest form, okay? So we have to express these in their lowest form. I hope that is okay for everyone. So cofactors or relatively prime just means expressed in their lowest form, okay? Lowest terms. So here, is this our lowest term? Obviously not, isn't it? So we can have a number that can go into 99, that is, right? No, we made a mistake here. This is not x, isn't it? So this is 100 minus, this is 10x, right? Yeah. So this is 10x because we're having 100 minus this, isn't it? I thought it were doing this. So it's 100 minus this, which is 10x, meaning this will be 90x, isn't it? Not 99, 90x, like this. So now dividing both sides by 90, it means, so this is our A, this is our B in our lowest term now because they need to be cofactors. So which number can go into these? I think we can have, which one, a 3? Which number can go in this? So this in the lowest common, in its lowest terms, you can first divide by 2, then check again if you can have another number. But in its lowest term, after finding, I found a 35 over 15. So this can be broken down into 35 over 15. But you can just start from a 2, for example, you say 2 in there is 45, isn't it? 2 in there, you find the number, then again, find the lowest until you break it down to the lowest term. But the final answer should be 35 over 15. Of which 35 over 15, we can still have another number going in, isn't it? Which is 5, right? So 5 into 35 should be 7 over 5 into that is 3, right? I think this would be the lowest common denominator. So I think our final answer should be 7 over 5. So I'll try to break this down number into in the lowest terms rather. Okay. I hope you've understood that. Let us do another example. So let us now look at 3.312 bar. So the bar now is on two numbers, 1 and 2. So the first thing that I said is let x be equal to the original, isn't it? So we're going to say let x be equal to 3.312 bar, right? And the second thing that I said, now we need to move the point to where we're only going to have on the right side, we only have the repeating decimal. So which number can we multiply? Obviously, we multiply by 10, isn't it? So we're just going to say 10x is equal to, then we're going to have 3.12. We're only having them on the right. Then the next thing we need now is to multiply them again to the point where we are going to have, we need to cover this now, the repeating, isn't it? So to do that, we need to multiply this 10x by 10 again, isn't it? By 100, because now we need to move 1 2 times, isn't it? So we're going to multiply this 10 and this side as well by what? By 100 in order for us to move 2 steps. So this 10 times 100 is just going to give us 1000, isn't it? So we're going to have 1000x is equal to this multiplied by 1000, we just move 2 times. So we're going to have 3312.12. Then this repeating like this. Okay, then from here, we can subtract the last 2 equations, like I said. So we're going to have 1000x minus 10x is equal to, we're going to have again this 3312.12 bar minus this here 3.12 bar, like this. So having subtracted this, when you subtract this from this, what are we going to have? It's 990, isn't it? So this is 990x is equal to, then you can subtract this. Please do this mathematics. Don't try to be clever. So you try to do this, okay, minus the old way of doing mathematics. So this one will be 33.12 bar. So these repeating ones will always cancel because of this. So these will just cancel. Then what are we going to have with this? You can get a 1 there. We're going to have 12. So our answer is going to be, we're going to have 9 here. And then this will be 7. Then this will be 3, 2, isn't it? 2 and a 3. So this is going to be our answer. So here we're going to have 3, 2, 7, 9. Okay, there's no point here. So then we can divide both sides by 990. Even this side by what? 99, like this. So we're going to say our x is therefore equal to what? So you can find the lowest common denominator there. I think 3 can, or a 2, right? I think we can find a number that can go in both. 2 is always the preferred number, isn't it? So you can do 2 into that. When you simplify this in your own time, you will find the answer to be 1093 over 330, of which I believe 3 is the one that is able to go into both of them. Okay, so this you would have found and expressed in the form A over what? Over B. So this is pretty much how you do it. Okay, maybe I can give you this exercise, then you can pause the video. You can, if you're watching the recorded, you pause the video. I want you now to try out this. Express this 5.123. Everything here is the bar. Okay, so I'll just pause this recording and we can just try out this in like 3 minutes and then I'll resume the class.
Guys, and Mr. saying anything, we can't get you. Can't see anything.
Oh, I was talking to myself. Sorry about that. Okay. So I was saying this one is already, we already have the decimal immediately. We have the repeating number immediately after the decimal. So there's no need of us multiplying by any number in order for us to have the decimal after, immediately after. So here we just go straight to covering the repeating decimal by moving it 3 times in this case, right? So that we can cover the whole repeating number. So in this case, we're going to say x is equal to this, the original. Then we're now going to multiply it by 1,000. So we're going to say 1,000 by x, and then this will move 1, 2, 3, isn't it? So we're going to have this, then we're going to have the repeating there. So now the only thing that we need is to subtract. So this minus this is 1,000 minus x. Then we're going to have this minus this. So we have this, which is here, minus 5.123, which is repeating. So there again, it's the same thing now we have been doing. So this minus this will just give us 999, isn't it? So 999x is equal to, when you subtract this and this will go, the repeating. So we'll just have this number minus 5, right? Which should be able to give us 5118. Then you can divide both sides by 999, this side as well by 999. So we express this number now in its lowest form. We can say x is equal to, I think 3 can go in here. So 3 in there, we're just going to have, so you can divide both sides by 3 to just convert it in the lowest common denominator. Then you're going to find 1706,333. I think it cannot be simplified further, so you leave it in this form. Then you would have expressed it in the form of A over B. So remember, this has to be in the lowest form, in the lowest terms. Okay, and that is all about this, but let me just give you maybe one more when it comes to negative numbers, but the whole procedure is the same. So now let's say we have this, maybe we can do it together. Let's say you have been given negative 5.71, and you have been taught to express it in the form A over B. So it's the same procedure. We just say let X be equal to what? The same thing, let X be equal to negative 5.71, which is our original. Then, okay, which one is repeating? Here, the one which is repeating is the 7, like this, the horse 7-1. So what we're going to have is since we already have it immediately after the point, so just go ahead and move it twice, isn't it? So we're going to say 10x, right? Because we need to move it, it's 100, isn't it? 1, 2, so we multiply by 100. So it's going to be 100x is equal to negative 5. Okay, so negative 571.71 bar, like this. Then you can just do the direct subtraction there. So we're going to have 100x minus x is equal to this minus this. So we're going to have minus 571.71. Then we're going to say minus. Now, here you have to be careful. So it's minus, right? Then you open bracket minus 5.71, like this. Then obviously this is just going to give us 99x is equal to, so negative 5. So this will have, okay, let me just erase this. Okay. Okay, I hope I've resumed the recording. Okay, so this will be equal to, so we're going to have 571, she's a negative, so negative 571.71. Then we're going to say here, this will become a plus because negative times positive. So plus 5.71 repeating. Okay, so you know these two cancel. So we're just going to have 99x is equal to, so having subtracting these two, what's the number going to find? It should be 566, right? 566. Then you can divide both sides by 99, this side as well by 99. Then these two can cancel. Our x is equal to, then is there any number that can go into these two? I believe there should be nothing, isn't it? If you try 2, 2 is not going in there. 3 can go in there, but not in there, isn't it? So you just leave it as 566 divided by 99, and you can leave it right here. Okay, so that is all how you deal with the negative. I believe it's just at this point. So now you can go back to your quiz question. The question that you were given in the quiz, I believe we have dealt with something like that. And that is all about the rational numbers. So what I believe we're going to do now in the next class, I want to talk about the complex numbers, I think just a bit so that you can sharpen and you don't have any doubts concerning the complex numbers. Okay, but for now, I believe this will do. So on Thursday, that is, we're going to meet, we'll start a new topic. So I'll just spend 30 minutes or 20 minutes just to conclude on complex numbers. And then after that, we're going to start our new topic. Okay, unless there is a question, any question? Okay, and on our final answer, the x, that one was the negative, isn't it? It was negative 566. I think I wrote positive. Yeah, so it should be this. It should be negative 566. I think I forgot to put the negative there. Okay. And on Wednesday, as we'll begin the next class, we'll only accommodate those people that would have paid. So tomorrow, we can come and make the payments before having the classes for economics. Okay. All right. Other than that, we call it a day. Have a good day.